The cosmological constant problem. Look out your window. Go on, if it's night, just look up at that dark, empty space between the stars. It looks like nothing, doesn't it? A perfect, serene void. A canvas of pure nothingness. But what if I told you that this nothing is the most something thing there is? What if I told you that empty space isn't empty at all, but is in fact unimaginably heavy, dense, and bursting with a hidden energy so powerful it defies all logic? And what if this secret, this property of the void itself, contains the ultimate answer to the fate of our entire cosmos? Welcome, travelers. Today, we are diving into the deepest, most profound mystery in all of science. A problem so vast and so baffling, it's been called the worst theoretical prediction in the history of physics. This is the story of the cosmological constant problem. And it's a story not just of math and telescopes, but of a ghost in the machine of reality. To begin, we need to go back to 1917. Albert Einstein, having just shattered our understanding of space and time with his general theory of relativity, was trying to understand the universe as a whole. His equations were beautiful, but they had a strange implication. The universe should be either expanding or contracting. It couldn't just be. But everyone knew the universe was static, eternal, and unchanging. The stars were fixed in their celestial spheres. So Einstein did something he would later call his greatest blunder. He introduced a fudge factor, a mathematical stopgap. He called it the cosmological constant. It was a kind of anti-gravity force, woven into the very fabric of space itself, that would push back against the collapse of the cosmos, keeping it perfectly balanced and still. And then, just over a decade later, Edwin Hubble looked through his telescope and discovered something that would send shockwaves through history. The universe was expanding. The galaxies were all flying away from each other. There was no need for Einstein's balancing act. He threw his constant out the window, and for decades, it was forgotten, a dusty relic of a wrong idea. But the universe has a way of bringing its ghosts back to life. Fast forward to the end of the 20th century. Astronomers, trying to measure how much the universe's expansion was slowing down due to gravity, made a discovery that turned reality on its head. They found that the expansion isn't slowing down at all. It's speeding up. Something is out there in the vast cosmic dark, pushing everything apart faster and faster. This something was given a name: dark energy. And the leading candidate for what this dark energy could be? Einstein's long-dead cosmological constant. The ghost had returned. The energy of empty space itself was real, and it was dominating the cosmos. But this is where the mystery deepens, from a puzzle into a true cosmic paradox. Because when physicists tried to calculate how much energy this empty space should have, they turned to the other great pillar of modern physics: quantum mechanics. In the quantum world, empty space is anything but empty. It's a seething, bubbling, frenetic ocean of activity. So-called virtual particles pop into and out of existence in a frantic dance, borrowing energy from the void for such a brief moment that they don't break any rules. This isn't speculation. We see the effects of this quantum foam in laboratories. It's real. And all this frantic activity, this chaos at the smallest possible scale, should be pumping empty space full of energy. It should be giving the vacuum a mass, a weight, a density. This is where our intuition completely and utterly fails. When we add up all the possible contributions from every quantum field, from every particle flickering in the void, we get a number. And this number is monstrous. It is an energy of empty space so colossal, so unimaginably dense, that if it were real, the repulsive force of this cosmological constant would have torn the universe apart in the first instant of the Big Bang. Atoms could never have formed. Stars could never have ignited. Life could never have emerged. The universe would be a thin, cold, expanding fog of nothingness. The math tells us that empty space should have a strength, a power of 1. But what do our telescopes, measuring the actual acceleration of the universe, tell us the strength of this dark energy is? They tell us it's a decimal point, followed by 122 zeros, and then a 1. Let me say that again. Our best theory predicts a number that is 122 orders of magnitude too big. That's a 1 with 122 zeros after it. This isn't like being off by a factor of 2 or 10 or 1,000,000. This is the largest discrepancy between theory and observation in the entire history of human knowledge. Imagine calculating the weight of a single feather, and your theory tells you it should weigh as much as 1,000,000,000, trillion of our entire observable universes. That is the scale of our error. It is a failure so complete, so spectacular, that it's almost beautiful. This is the cosmological constant problem. Why is the energy of the vacuum so infinitesimally small, but not quite zero? Who or what dialed it down by 122 orders of magnitude, leaving just the faintest whisper of a shadow? Just enough to gently nudge the galaxies apart, but not enough to prevent us from existing? This isn't just a math problem. This is a cosmic question. It's as if the universe has a fundamental setting, a dial for the energy of nothing, and for some reason, it is set to a value that is just right for complexity, for stars, for planets, for us. This touches on the idea of the anthropic principle, the controversial notion that the universe we observe must be compatible with the existence of conscious life to observe it. Are we in one universe among a vast multiverse, a cosmic landscape where every possible value of the constant exists, and we simply find ourselves in one of the rare, lush gardens where the numbers allow for life? It's a staggering thought. It turns our universe from a single creation into a single page in an infinite library of realities. Other theories are even more mind-bending. What if this energy is an illusion? What if gravity works differently than we think? Or, and this is my favorite, what if our reality is a projection? What if the three-dimensional space we live in, with its dark energy and expanding galaxies, is actually a hologram, encoded on a two-dimensional surface at the edge of the cosmos? In such a model, the properties of the vacuum might be translated into a different language, where this terrible miscalculation simply vanishes. The problem isn't solved, it's transcended. This is the true magic of this mystery. It's not a locked door, it's a portal. It's a signpost pointing to a reality far stranger, far more interconnected, and far more mystical than we ever dared to imagine. The answer won't just be a new equation, it will be a new philosophy. It will tell us what the cosmos truly is and what our place within it really means. The emptiness you see out your window is not passive. It is not a stage. It is an active, dynamic participant in the cosmic story. It has a mass, a presence, a memory. It is the silent, dominant character in the tale of everything. And we are only just beginning to learn how to listen to it. The journey to understand this is the greatest adventure of the human mind. And you are a part of it. By questioning, by wondering, by looking up at the night sky and feeling that awe, you are participating in this grand search for meaning. If this journey into the heart of the void captivated you, if you felt that spark of wonder, then do me a favor. Give this video a thumbs up. and subscribe to the channel so you don't miss our next dive into the mysteries of the cosmos. The conversation is just beginning, so please, leave your thoughts, your wildest ideas, your own theories in the comments below. What do you think the answer is? I read every single one, and if you want to go even deeper down the rabbit hole to explore the idea of a holographic universe and a cosmic multiverse in stunning detail, I invite you to check out my book, Holographic Multiverse. We'll explore how the very nature of reality might be a cosmic code, and how solving mysteries like the cosmological constant could require us to rewrite the very definition of existence. The link is in the description below. Thank you for traveling with me today. Remember, the universe is stranger than we can suppose. Keep looking up.